In Algebra 1, there are three different kinds of functions that we will focus on: linear, quadratic, and exponential functions. Let's try to distinguish or recognize between these different kinds of functions. Alright, let's try to compare the different kinds of functions in terms of their graphs. So the very first is our linear function, and the graph of a linear function is just a line. So if you see a line, that's a linear function. That's a graph of a linear function. Your line can be decreasing from left to right, just like this, or it can be increasing from left to right, or it can be a horizontal line. All right, so a linear function has a graph of a line. For a quadratic function, the graph of this quadratic function, it's like a letter U, and you call it a parabola. All right, you call it a parabola. So your parabola can either opens upward, just like this, or you can have a parabola that opens downward. Okay, so either opens upward or opens downward. Now for exponential functions, so the graph looks like this. So in an exponential function, the graph, it's different from a parabola. If you compare the two, it's different than a parabola. The graph can be increasing from left to right, rapidly increasing from left to right. You call it an exponential growth. Or your graph can be decreasing from left to right. You call it an exponential decay. It's different from a parabola if you compare it. Yeah, so your exponential function can either be a growth, just like this, or a decay. So these are the three different graphs for each type of function. Now let's compare the different types of functions in terms of their equations. Now it is understood here that the variable y will have an exponent of 1. All these kinds of function will have the exponent for y, the number at the top of y is 1. So as you can see here, it's an invisible 1, invisible 1, invisible 1. So that's what we assume. And then we're just looking at the x's. So if you see for a linear function, if you see that the exponent of x is only 1 here, just like this, the exponent of x is equal to 1, you call it a linear function. All right. If the exponent of x is equal to 2, just like this, you see an x squared, that's a quadratic function. The highest exponent in the equation is 2 for x. So that's a quadratic function. And for exponential function, if you see that your variable x becomes an exponent, just like this one. So you see that x is on top of 2. If it becomes an exponent, you call it an exponential function. All right. So that's the difference in terms of equation. All right. The last part will be about tables. How do we know if this table is linear, quadratic, or exponential? All right. So here's how you do it. So first, we assume that your x here have equal distances. Like here, as you can see, the distance of each number is equal to 1. So see, from 2 to 1 is 1, from 1 to 0 is 1, 0 to negative 1 is 1 unit, and so that if the x's have equal distances, we just focus on the y. All you have to do is subtract the consecutive numbers here. So for example, this will be the first consecutive number, -7 and then -4. So you subtract -7 and then a negative and then a -4. All right. You subtract the two numbers. That's equal to a -3. -3. All right, and then we subtract the next pair, -4 minus 1. So -4 parentheses minus another -1. Okay, and if you use your calculator, that's a -3. And so next is -1 minus a +2, which is a -3. Okay, and then 2 minus 5. 2 minus 5 is -3. So you just subtract each consecutive number. All right. So now, if you see that your answers are all the same for the first subtraction, you call it common difference. Then this table is a linear. So if you subtract for the first time the y's for each pair of y and you get the same number, that's a linear table. So this table is linear. All right, let's take a look at this table, and we want to know if this is linear, quadratic, or exponential. We always begin with linear, okay? So for linear, we just subtract consecutive numbers. So we have 16 minus 2, that's equal to a 14, okay? The next pair will be +2 minus a -2. That's actually a +4, okay? Next will be a -2 minus 4, which is a -6. Then next will be 4 minus 20, which is a -16. Right? And then the last will be 20 minus 46, which is -26. All right?
So if you subtract for the first time and you don't get the same answers, then that's not a linear. Okay, because linear is when you subtract for the first time and you get all the same answers. For quadratic, all you have to do is use the previous answers and do the subtraction per pair. So here we subtract again 14 minus 4. 14 minus 4 is 14 minus 4 is a 10. Okay, 10. The next pair will be 4 minus negative 6, which is equal to a 10. Okay, the next pair will be negative 6 minus negative 16. Okay, negative 6 minus negative 16, which is a 10 again. Okay, and then negative 16 minus negative 26. Be careful with your subtraction here. So you have a positive 10 again. If you subtract for the second time and you get the same answers, that's a quadratic. All right, so this table is quadratic. All right, now let's look at our final example. So we have this table. We want to know if this is linear, quadratic, or exponential. So we always begin with linear. We subtract each pair of numbers here. So we have negative 1 minus negative 6, which is positive 5. And then the next will be negative 6 minus negative 36, all right, which is a positive 30. And then the last is negative 36 minus negative 216, which is 180. So as you can see, I subtracted for the first time and I did not get the same answers. Therefore, that's not linear. Okay. Then we do the second subtraction to know if this is quadratic. So the first pair will be 5 minus 30, which is negative 25. And then the next will be 30 minus 180, which is 30 minus 180 is negative 150. And as you can see, the answer for the second subtraction is not the same. Therefore, it's also not quadratic. Okay. But does it mean this is automatic exponential? No, you have to check if this is really exponential. And to check for exponential, all we have to do is to divide. Instead of subtraction, we divide each pair. So the first pair will be negative 1 over negative 6. All right. The next pair will be negative 6 over negative 36. And then the next pair will be negative 36 over negative 216. Okay, so we divide this time. For us to know if it's exponential, we divide each pair. So what's negative 1? 1 divided by 6 is 0.167. Okay, and we divide negative 6 by negative 36, same number, 167. And then negative 36 divided by negative 26 is 0.167 also. So as you can see, I got the same answers when I divided each pair. So if you get the same numbers, then this table is exponential. Okay, exponential. So this is exponential. All right, that's how you check for exponential tables.